This video is about completing the square when a is not 1. So if we're trying to solve a quadratic equation and we don't have the leading coefficient equal to 1, if it's 2x squared or 3x squared or 4x squared, something like that, how do we complete the square? That's what this video is about. How do we solve that equation? Okay, so we're just going to look at two examples. The first example is going to be pretty simple, and the second example is going to be rather complicated, and you'll see why in a minute. So our first example is 2x squared plus 20x plus 30 equals 12. What does this mean? This means that there's some x, or maybe more than one x, in which when we plug that number in for x, 2x squared plus 20x plus 30 will get you an answer of 12. And we're looking for what that value of x is. That's what solving this equation means. So the first thing we're going to do is divide everything by a. Here a is 2 because we have 2x squared. So we're going to divide everything on this side by 2, but whatever we do to one side of an equation, we must do to the other side. So we divide the other side by 2 as well. So when we do that, 2x squared divided by 2 is going to be x squared. 20x divided by 2 is going to be 10. And 30 divided by 2 is going to be 15. 12 divided by 2 is 6. So we divide all our terms by 2, and we get x squared plus 10x plus 15 equals 6. Now this is an equation that we already know how to complete the square for. So I could stop the video right here, but just as a quick review, let's go ahead and finish this and complete the square to solve that equation. So we see that 15, and we need that to be 25. Why? Because we have 10x as our middle term, and we know, a little shortcut, we know that we can take half of 10, which is 5, and square it to get 25 to figure out what that third term has to be. So we want to make that third term 25. In order to do that, we have to add 10. But if we add 10 to one side, we have to add 10 to the other side as well. So we go ahead and do that. So if x squared plus 10x plus 15 is equal to 6, then if we increase x squared plus 10x plus 15 by 10, it must be equal to 16 now. So x squared plus 10x plus 25 equals 16. Now we have x squared plus 10x plus 25, which is a perfect square. So we can write it as a perfect square. It's x plus 5 squared. So x plus 5 squared is equal to 16. Because x squared plus 10x plus 25 is the same thing as x plus 5 squared. That was the whole purpose of completing that square, was to make it a perfect square so we could write it as a binomial squared. So we have x plus 5 squared equals 16, so we know that x plus 5 could be 4, because 4 squared is 16. X plus 5 squared could also be negative 4, because negative 4 squared is also 16. So if x plus 5 equals 4, then x can be negative 1. X must be negative 1. And if x plus 5 equals negative 4, then x must be negative 9. So those are our two solutions. X equals negative 1 and x equals negative 9. What does that mean? That means that if we plug in negative 1 for x into our original expression, 2x squared plus 20x plus 30, we will get an answer of 12. Also, if we were to substitute in negative 9 for x in that expression, 2x squared plus 20x plus 30, we would also get an answer of 12. So that's the simple example. The only new thing there was dividing by 2. That was the only new thing. So now we're going to look at the difficult example. The only reason this is more difficult is because when we divide, we're going to get fractions, and we have to deal with fractions. We don't like fractions. They're harder to deal with than just using integers. But you know what? Them's the breaks. We're going to have to. So we're going to divide everything by 3 because we have 3x squared. So we divide both sides by 3. When we divide every term by 3, we're left with x squared plus 10 thirds x. Oh man. Plus 10 equals 40 thirds. Now we look at that, we don't like it. It looks harder, and it is harder. It's more complicated, but the steps are still the same. It's just the computations become more difficult. So we have to figure out, what does this 10 have to be? Well, it has to be 25 ninths. 25 ninths. Oh man, how did we get that? Well, remember we take that middle term, which is 10 thirds, and we find half of it. Half of 10 thirds is 5 thirds. And then we square that. And 5 thirds squared is 25 ninths. So we need to make that 10 become a 25 ninths. How do we do that? Well, first let's convert that 10 into something with ninths to get that common denominator. So let's change the 10 to 90 ninths, right? 90 divided by 9 is 10, so that makes sense. I didn't really change it. I just made it have a common denominator of 9 because we were trying to get to 25 ninths. I'm going to do the same thing with that 40 over 3. We want to have it over 9. So 40 thirds, an equivalent fraction of 40 thirds that has 9 in the denominator, is 120 ninths. If you don't know how to get a common denominator, I suggest you watch a different video than this one. So we have 90 ninths instead of 10. We have 120 ninths instead of 40 thirds, or 40 over 3. And now we need to get that 90 ninths to be 25 ninths. How do we do that? We subtract 65 ninths. But if we do it to one side, got to do it to the other side. So when we do that, we get x squared plus 10 thirds x plus 25 ninths. What does that equal? Well, 120 ninths minus 65 ninths is 55 ninths. So these are all looking really complicated, and you might be getting lost, but you might be getting lost just because of the fractions. And that's just simple arithmetic of fractions. I'm saying the word simple because we learned that, I don't know when, in 4th grade maybe, but it's really not that simple. It's kind of, people struggle with it, all right? And it's okay to struggle with it, but you got to figure it out, and you got to do it right. So we have x squared plus 10 thirds x plus 25 ninths equals 55 ninths. We know that that expression on the left of the equation is a perfect squared trinomial, so we want to write it as a squared binomial. There we go, x plus 5 thirds squared. Remember that 5 thirds came from taking half of 10 thirds, right? And that's equal to 55 ninths. And now we do the same thing we did before. We have to do the square root and the negative square root. So x plus 5 thirds has to be the square root of 55 ninths. And x plus 5 thirds could also be the negative square root of 55 ninths. And we just subtract 5 thirds from both sides. And we got x is equal to negative 5 thirds plus the square root of 55 ninths. X equals negative 5 thirds minus the square root of 55 ninths. That's looking all complicated. It is kind of complicated, but it's just a number. And if you want to get the decimal approximation of that number, in order to graph that, if we were going to graph it at some point, or you just wanted to get an idea of how big is that number, looking at it, I can't really tell, go ahead, plug it into your calculator, see what you get as a decimal approximation. That's the end.